The current record for number of digits of pi calculated is roughly 30 trillion digits, which is surely deliberate because it is roughly pi times 10 to the power 13 digits. Better still, this record was created on Pi Day. For the curious, all the records broken in the previous decade all used the Chernovsky algorithm based on this monstrous formula. We will not talk about how to derive this formula because to understand it fully, it requires a year's worth of videos. Instead, we will explore a much simpler but only slightly less computationally efficient class of algorithms known as Machin-like formulas, and the simplest of which only relies on this pretty easily understood formula. Using a more complicated algorithm similar to this, a record trillion digits of pi was calculated back in 2002, and we are going to see how this type of algorithm works. The main mathematical concept behind this family of algorithms is just some basic complex numbers manipulation. It is actually possible to use geometry to prove this simple formula, but in general, this kind of diagram will get extremely complicated to draw for just slightly more complicated formulas. So we still opt for the algebraic method for much easier generalization. If you have not learned about complex numbers, head over to Welch Labs for an amazing introduction. But here is a quick refresher on the basics of complex numbers. Complex numbers can be written in two forms, the rectangular form as well as the polar form. For the sake of simplicity, we use a bracket with a and b inside to denote this complex number in rectangular form, and a square bracket to denote the complex number in polar form. This is a formula that converts between the rectangular and polar form. There are definitely concerns over the range of the inverse tangent function, but for the purpose of this video it will be okay to leave it like that. For multiplication of complex numbers in rectangular form, it is rather messy, while in polar form multiplication is pretty easy. And these two very basic things you know about complex numbers would be enough for the discussion afterwards. We now consider the product of these two complex numbers. We use this product formula for the rectangular form here and get the product to be 5 plus 5i. However, we can also use the change of form formula, plug all these numbers in, and then we get the equivalent expression written in polar form. Now compare with the product formula in polar form. We can see that these two numbers should add up to pi over 4, which is one formula of pi that we saw a minute ago. Basically, by expressing the same thing in two different ways, namely rectangular and polar forms, we see something new. Of course, this is only the simplest such example, because by considering other similar special products, we obtain similar forms of identity, and the list here is not exhaustive. In particular, this boxed expression was discovered by Machin, so this entire family of formulas is known as Machin-like formulas. But why are these useful in computing pi? These formulas are coupled with this series expansion of inverse tangent function for computation of pi. For this series to make sense, the absolute value of x has to be sufficiently small, but in all those formulas, the argument of the inverse tangent function is smaller than 1, so we are good. In fact, the numbers inside the inverse tangent function should be as small as possible, because each term in the series will get smaller, faster. This is why this formula discovered by Machin is computationally more efficient, as these numbers inside the inverse tangent function is much smaller. Now of course, we can make the formulas more complicated in hopes that some of these terms will be very small. But there is always kind of a trade-off, because small terms mean less computationally efficient and smaller terms mean more efficient for an algorithm. So we need to balance these two factors when it comes to choosing an algorithm. This formula strikes a balance between these two factors, and it was one of the formulas used to create the record 1.2411 trillion digits of pi calculated. For the sake of completeness, here is a very short proof for the inverse tangent series using very elementary calculus. So you have seen how pi can be calculated to trillions of digits, but the bigger question is why? Does it have any practical purposes? Well, yes, but not in the way that you might have imagined. 200 digits of pi already give you subatomic accuracy even when you calculate the volume of the entire observable universe, so using it on Earth is a massive overkill. The main purpose is actually testing supercomputers and current technology in general. And the most recent record was broken using cloud, the first time in the history of pi computation. There are actually a lot of things to explore around this topic that I am surprised not more math channels talk about it. I get much more interested in this topic during my research for this video, and I will put links in the description as some pointers for you to learn more. If you enjoyed this video, give it a like and share this video. Don't forget to subscribe to the channel with notifications on. See you next time!